Welcome to Old Iron Machine Works. My name is Gary. In this video I will be repairing a 817 Waukesha water pump belt drive, and I will be calling it quality control or lack of. I'll start by telling you the basic setup. You would have a big heavy duty snap ring that would go in that groove, and then the bearing would go up against the snap ring, and then the spacer would go up against that bearing would go up against there. When everything's installed on the engine and you put the front pulley on and put the nut on, everything tightens up, sandwiches up, and then right inside of there the big bearing will have a shoulder that presses in, and then the snap ring holds it. So that sets all the clearance. Shaft pulls up against the spacers, tighten it up, it pulls everything nice and tight. And then you would have your mechanical seal, and then the impeller. Well, one of our customers bought this water pump brand new many years ago and put it on the shelf for a spare, and they just got around to needing to swap it out. And once they started putting it on the engine, they realized it was locked up and wouldn't turn. And you can see the height, that's an old impeller. And when the impeller is installed in the housing, it's pretty well flush, and then with the top gasket that would give you your clearance. So I figured the thing just got bumped, or when it was brand new they just did not get the clearances set properly. So I was really expecting it to just be just reset the impeller either in or out, whichever way it needed to go. I've already had the cover off once. I just stuck it on there just for the video deal. But if you see the straight edge, that straight edge should bridge all the way across the housing and should not touch the impeller anywhere. And as you can see by the rocking of it, it was actually springing the cover, it was so bad. But on one end, and here you'll now see why. When the housing was machined brand new, they did not put enough relief into the housing for the impeller to fit down inside. It's supposed to be down there and sitting up on top of that lip. So it was pretty much sandwiched in between there. And this is where the quality control or lack of. I understand in certain operations stuff happens, but I'm kind of a little surprised at some point nobody actually caught that during assembling the pump. So basically I just got to set it up and go in there and machine that flat spot. Well, you got the taper and then that flat spot right up there. Well, that clearance to there is fine, but all that right there needed to be machined out. So now I just got to set it up and remove that material. Wanted to point out, we are not the ones that originally sold them the pump. If you've watched any of my other videos, I had a video where I made these, what I called booster chairs, for the mill out of some old pistons. They were made for another project that I have not got back to. But they actually worked out great for this project. When I made them there, they would bolt solid to the table. And on this application, I needed to turn them in to where they would fit tight up against the housing on the water pump, because I need to center off that center hole, and that also was going to be the center hole that I was going to use for clamping it down. So by clamping the pistons nice and tight up against there, it allowed it to set pretty accurate without moving around, and let me center it up. Here I'm using a Blake coax indicator. These things, I love them. They work great. I'm not going to get into exactly how they work. Right now there's lots of videos out there, that talk about that. But the movement you see right there, it's basically a half a thousandths from line to line. So it's pretty hard to ever get zero movement unless you go in and make another cut. But anyway, I got it centered up pretty good now. Here I'm just putting a spacer. Actually, it's a nut off of one of the little compressor pistons. Anyway, just putting it on with the one nut, and then that'll get tightened down really good, and that'll basically be the only thing that holds it down tight against the table. But being that the pistons all bolt down separately, it does make for a pretty solid solid mount. Here I'm having to make up another boring bar to go into boring head. At work I only have a 3-inch Criterion boring head, so I either went home to my shop and got my 4-inch boring head, or made up a cutter to fit in the 3-inch. So I basically just took an old boring cutter, heated it up, bent it, went ahead and heated and took off the carbide, ground an area to silver solder another piece of carbide, and then it'll just be all ground and shaped. Here I just silver soldered right to the tool and right to the back side of the piece of carbide. Now I'm just going to set it on there and just melt them in together. That's one of the things I love about the carbide. You can pretty much heat it up and solder them to just about anything, and it doesn't affect them a bit. You still got to use the diamond wheel to sharpen them up. Okay, here we got it pretty roughed out, and you can see the original backing. That's the carbide, that's the original back, and that'll all be ground off, and then all that back support will be ground off. Now with the carbide, you can rough them out. Well, you just use a regular grinder, to remove all the softer material, and you can rough out the carbide with a green wheel. But the green wheel does fracture a little bit, so definitely a diamond wheel does give it a better job, better finish. Now this is a diamond wheel I'm using right now just to give it the finished edge. With this particular cutter, it's never going to be hogging any heavy material. So the most critical thing is just right there. Just get your angles where your leading edge is your front surface. Like I say, the angle's not that big of a deal because it's just going to be taking a light cut. Now here you can see, of course, you want the tip when it's up in the tool, to be your main edge that's making contact. Now being that the thing is bent out a little bit farther, right there you want to grind a flat spot. And the reason for the flat spot is so you can kind of work the tool. I already ground the flat spot, and it lets you kind of work it, get it kind of seated into one spot. And this way, no matter how many times you take that cutter in and out, you'll always repeat right back to the same place and eliminate risk of it actually slipping inside and moving. Now here I was actually setting the quill stop because I was going to use the power feed quill on it, but I ended up, as soon as I started machining, it was a little bit hard to have good control over the depth, so I ended up just locking the quill and just using the table, and just raising the table up nice and slow, and you generally get a lot better, smoother cut doing that. Now I do realize that this setup looks a little sketchy, but the amount that I was machining off, it was actually quite rigid and actually kind of worked quite nicely. During my editing, I never know how much of the machining to leave in it and how much to take off. The last thing I want to do is bore somebody to death, seeing the exact same thing. So I actually did take a lot of the machining out. Hopefully it won't be still too boring. I was trying to do a lot of editing on this video at the same time. Randy Richard had his live stream for Look-See in my grandfather's toolbox, so I was getting quite distracted quite a bit. But anyway, go check it out. It was pretty cool. Here you got a good look at the area that got machined. Just needed that outside edge removed. I guess I should point out the fact that the shaft that came out of it was bent and the impeller was tweaked, so we just ended up putting a new water pump kit in it. Here, just giving a rough check to just make sure it's got the clearance. Now some pumps are very critical on the clearance, these not so much. If you put the impeller pretty much flush with the top when you press it on, The thickness of the gasket is all the clearance you need there. Here we got the new shaft in it. We got the new mechanical seal in it. Ready to press the impeller on. On these particular pumps, I start out with using the square shoulder on the press right up against the impeller. Keeps it nice and square. You can see on the bottom I screw a long nut on the shaft, so where I'm pressing is not putting any stress on the bearings whatsoever. It's just pushing directly right on the shaft from the bottom. But on these here, the shaft protrudes out slightly past the impeller, so I just put a little washer in there with a hole in it for clearance, just to get my impeller depth. On these impellers, on a lot of water pumps, I'll put some Loctite on when I press them on, but on these particular impellers, it takes a lot of force to press it on the shaft, and sometimes I'll even use a anti-galling lubricant just to kind of help it slide on without galling. Once again with the pointer right there, just showing the area that I had the machine off. Now you can see where the shaft protrudes up above the impeller. Well, the cover does have a relief area just for that. The pump is done, ready for paint and installation. If you like this content, please subscribe and give a thumbs up. It's always very much appreciated. Once again, thanks for watching, and hopefully we'll catch you on the next video.